I'm Jim Anderton, and this is the Industry Insights and Trends podcast. On this show, we'll explore the length and breadth of 21st century engineering, from civil engineering mega projects to innovation at the quantum level. We speak with subject matter experts and industry watchers from every sector of the engineering discipline. On this episode, AI in manufacturing, hope or just hype?
Artificial intelligence. It's everywhere in mass market media, in commercial media, in industrial media. Everyone is covering it. Everyone is talking about it. Everyone is thinking about it. Now, the implications for society as a whole are obvious, but what are the implications for manufacturing? And undoubtedly, there are implications. I'm joined by senior editor Mike Ouellette with engineering.com. And Mike, you cover artificial intelligence for this sector specifically. And to kick off immediately, let's just start with the obvious question, which every professional in manufacturing has been asking about artificial intelligence. Is AI just hype?
The quick answer to that, Jim, is no. But there's nuance to everything, right? So if you look at how it's covered in, popular media in the news and things like that, and the things that people get to use like ChatGPT, I mean, there's a little bit of hype to that in the sense of its functionality, but manufacturing is different. And the way you look at it with manufacturing is that you're trying to make decisions based on data very quickly. And what AI does is help you do that by collecting all the data and giving you options, right? But, when I first started covering this, I had the same question, whether it was hype or not. And then I went to this conference, ARC Leadership Forum in Orlando, start of the year. And I was wondering, is this hype? But then I took a look at all the massive companies that were there. These huge companies were spending tons of money developing it. There's a lot of suppliers, like the big device suppliers, Rockwell, Schneider, Siemens. They're putting a lot of money into developing it. And then when I looked at the roster of attendees at this ARC Leadership Forum, the top 30 companies that were attending had a market cap of about 4.2 trillion. That's with a T. So that would put them, if they were a country, that would put them between Germany and Japan and the size of value they had. So with that kind of money put, towards it, that just tells me that there's something to this. And we're just kind of starting to crack that egg.
Yeah. Mike, one thing I have noticed for sure from the financial media is the amount of money being thrown at AI startups is incredible. I mean, I didn't even think there was that much venture capital excess floating around to do that. It seems as if you want to start an AI, research operation or create an AI agent or something, Wall Street will line up and just dump a bucket load of cash at you to make this thing work. That suggests that the financial industry has some confidence that this is going to really, really be meaningful in the markets. But on the other hand, I hear people like organized labor who are standing up and saying, this has implications for overall employment. And one of the fears I hear over and over again is that AI may do to white collar work what AI or what automation did to assembly line work before, basically. Is this thing going to slaughter jobs as we know them in the sort of the middle of the market?
Well, that's the big question. I think a lot of the fear comes with the speed at which we're adopting this, right? Like if you look at the World Wide Web, that kind of became publicly available in the early 90s. And it wasn't until, 2010, so like 20 years before it became kind of like ubiquitous in society. With AI, it's been like a matter of a couple of years right now, and it's everywhere. So that's kind of where the fear is coming from, and the uncertainty as to what it's capable of doing. But from what I've seen, it's in manufacturing's terms, it's really not going to replace the people that work there. In fact, it kind of needs them. I spoke with Claudia Chandra. She was at Honeywell. She's a senior vice president of offer management. She develops use cases for companies looking to use AI. And she was very clear that you need that human domain knowledge to make the AI do what you want it to do, right? When you're training AI in manufacturing, you're not doing it like they did with ChatGPT, which is just taking all the available information we've got and stuffing it in there. You're training it based on your company's specific data. So you need to have these people in there to kind of help train it, get the data right, get it going kind of the way that you want it to go, in the direction you want it to go. So AI is not going to replace these people. It's going to change jobs. One of the big things that I heard was that, jobs will be transformed, which is good. It's disruptive, but it's good. Because it gives us a whole new kind of line of thinking and way of doing things. And one of the big companies using this is Petrobras. It's the Brazilian gas company. It's a state-owned gas company. And they've got like 25 or 30 different projects with AI going in there. And what they're going for is they want to make all their workers data analysts. So they want them to be able to interact with the output from AI and kind of make decisions based on that. So will it take all the jobs in manufacturing? Absolutely not. It's not going to run factories 24/7, 365, lights out manufacturing. It's not going to do that. But what it's going to do is change the way we do things, change the way workers on the line interact with data and their jobs.
Yeah. No, it's funny you mentioned that because it's one of the things we hear a lot about people working in the field, of course, is how do you train the large language models? And you hear about the using vast data sets. The general purpose AI people, of course, are tapping into things like social media, and they're looking for ways to sort of throw a lot of information at the system to train it. In manufacturing, it's a little more specific than that. I mean, you mentioned the fact that you're going to need people to actually train the AI. Now, I've heard two schools of thought about that, and one says that that's great, but once it's trained, it'll then take the ball and run with it. And at that point, it's not going to need any more training. Others who say no, it's a never-ending process, and it's going to need to constantly get that human input for the life of the system for it to adapt correctly. Do you think either one of those are on the ball here? Are we going to see a point where you teach it everything you know and then it throws you out the door, or is it just always going to need human input?
I think it's always going to need you, because like once you train it and you get it operating, it's working on that knowledge. But as it's doing that, you're developing more and more data, but you're not training it constantly while it's working. So you're developing this new data. And so it's going to have a whole bunch of new data left to train on again, to make better decisions, to make more nuanced choices in what it offers the humans that are using it. So then you'll do it, you'll take it offline, train it again. So I don't think it's ever going to sort of, kick humans to the curb, essentially. I think it's going to be us using it like a tool that's going to give us the most value in manufacturing.
We call it AI. And I remember 30 years ago, the big buzzword was expert systems. And the idea was to try and encapsulate, a manufacturing engineers or expert personnel's knowledge and build it into algorithms that help people make decisions. As I recall, I think General Motors had a program where if a senior engineer retired, the last 6 months of their job was spent in extensive interviews to actually try and encapsulate, that institutional knowledge that they developed over the decades. And we've had things like predictive analytics in manufacturing, for decades, where we have systems that input data basically, and it makes a rough prediction and says, you know what, you're likely to have a failure of that electric motor, and it's going to happen within the next 2 weeks, basically at a certain number of run hours, and you kind of plan your preventive maintenance around that kind of thing, and that has the feel of AI as well. So when we say AI, is this actually new, or have we actually been sort of doing this for years?
Yeah, it's not actually that new. I mean, it started off in development like the 40s, the 50s, and the 60s. But it took a break because we were still, like back in those days, you're still working on tubes for power and things like that. We didn't have the juice to make it do what we wanted it to do, but now we do. And, one of the talks that I saw at this ARC forum was Rockwell Cyril Perducat. And he's like, so now AI has come at a time when we have all the technology to feed it. And I think that's what the big difference is. We've been doing machine learning for a decade or more, tying that into vision systems and things. So we've been using it. It's just developed now more than really it's ever been in the past.
Yeah, yeah. I mean, is there a matter? We talked about the humans as kind of the input or the data set that AI uses to work. I'm thinking, what about the other aspects of the sensor side of the equation in manufacturing? I mean, decades ago when I was sort of mill writing, if you had an electric motor, you'd run over and put your hand on it and see if it felt like it was running hot. And that was sort of replaced by the next level of technology, which was we had crayons, which actually melted at a specific temperature, and you'd put an X or a mark on the body of an electric motor. So when you walked by, you could see if it melted, you had an overheating motor, and you didn't have to actually put your hand on it. And that was replaced by a thermocouple or temperature sensor, and you had a clipboard. hanging next to that critical electric motor, basically. And then, daily or even a couple of times a day, you walk by and you logged the temperature, and you could graph that and get a sense of whether you're winning or losing, or whether you're going to have a problem. And that evolved into remote sensors where the thermocouple was built into the motor, and it was through an Ethernet connection, wiring that information back to the maintenance engineer's desk. And then we have things like, vibration sensors that might measure, the noise or vibration in a bearing as it wears out. And so you sort of get this thing where you start instrumenting all your production equipment and aggregating vast amounts of data and throwing it up to a system in the front office, and so for these predictive analytics purposes and for these, preventive maintenance purposes. But the question is this going to be dependent now on the ability to have all your equipment sufficiently wired up that you can actually tell the AI something? Or is the AI going to somehow intuitively say, okay, I'm hearing a noise from that machine, and I know for a fact that means that it's that bearing that needs to be replaced?
Right. Yeah. You're going to need the stuff, right? You need the technology on the shop floor to collect this data. We call that kind of edge devices now. One of the big kind of buzzwords or trends is IT, OT convergence, right? You need to have your digitalization house in order to be able to collect this data and feed the AI. So, before you would, as you said, it would get all sucked into a manufacturing execution system maybe. But now, with the compute power we have, you can push that all into the cloud and store it there. So you don't have to pay for all the server space and do all the kind of grinding that you had to do back then with computers. It's all kind of done in the ether, right? Which makes it a lot more accessible to people. Smaller manufacturers can find value in implementing AI now because they have access to all of this compute power that they never would have had access to before.
Yeah, yeah. Like one thing that, like all great computer technologies, the acronyms are proliferating. Like toadstools, and the buzzwords are all over the place. In manufacturing, we hear a lot of them: causal, agentic, physical. Give us a brief primer. What do these things mean? When we hear these words, what do they mean?
Right. Well, so for manufacturing, there's a few types of AI. There's different types of AI, right? But there's a few types of AI that are going to be really useful. The one we all know is like the ChatGPT style, is a large language model, an LLM. And in manufacturing, that's going to be sort of like a human machine interface type thing. There's a lot of applications being developed around work instructions being developed this way, or asking like putting manuals into the AI and then having a worker be able to ask a question in whichever language they use, and the AI being able to give you the answer from the manual on how to fix a machine or how to produce a particular type of work. From there, we're going to go into kind of causal AI. And that's an AI that understands the cause and effect of different relationships in a complex manufacturing environment. Pardon me. So this is going to be like for root cause analysis, process optimization, predictive maintenance, right? Then you have agentic AI. And this is the type of thing that's going to be making decisions or offering options for decisions to management. It takes all the data, crunches it up, it marries it, compares it, finds the relations with it, and then says, this is what's likely going to happen. Here are your options for addressing that. And then the last one, physical, is relatively new, but it's essentially a combination of causal and agentic AI on the edge, so on the machine itself, like a motor with a PLC that has an AI function in there to make decisions and read data and figure out how the function of the equipment is working.
Yeah, yeah. Like it's one thing about any innovation in manufacturing, over the decades I've been covering this, I've heard over and over again, and I'm talking about from things like CNC machine tools right up to the digital twin, is over and over again I hear, that's great for Boeing, or that's great for Lockheed Martin, but I'm making door hinges here. I got 15 people in this shop cranking out here, and these super expensive, super complex solutions they're fine at the high end, but I'm gonna sit and wait until I can see something that I can afford and that delivers for me. Who are the people using this effectively right now? Is it the big boys I'm talking about?
Yeah, it's a lot of that. But there's smaller manufacturers too. Like I said earlier, there are use cases kind of up and down the food chain for this. But the companies with the capital to invest in it and the technology infrastructure to feed it are the ones that are going to kind of lead the charge on this. We're talking energy, big oil. Like if you think about like a pipeline, these companies have, their version of a PLC, um, thousands of them kind of up and down the pipeline at different stages, hundreds of miles away from kind of head office or where this is being uh, analyzed. And so they have all of that in the field already. It makes a lot more sense for them to be able to kind of attack this and kind of go for it. They also have a lot more money at stake. So the amount of value they can get out of it is quite high. But there's a lot that can be done with it. And when I was at that conference, there's a lot of smaller manufacturers or smaller developers finding ways that small companies can make use of this because obviously with the big money, it's the big players that are in there. So the smaller companies, the smaller AI developers are aiming at the smaller companies to find their value. So they're developing an AI application where you don't really need any expertise whatsoever to perform this predictive maintenance, and it can be done by workers on the shop floor and then feed it up to management so they can see how things are working and then make decisions based on that. For a small company, a little bit of value means a little bit of margin. It makes a big deal, especially when you're in a very competitive market and that competitive edge is small. If you can find a way to improve your productivity and efficiency using AI, I think that there's a reason to do it. I've heard probably one of the best quotes that I've heard about this is that if it's worthwhile talking about, then it's worthwhile talking about with AI. So if you're in a meeting, you're like, hey, we've got this issue and this issue and this issue. It's worthwhile examining whether AI can help you get through that quicker or find better solutions than you normally would.
Yeah, yeah, Mike, we're in the Wild West right now with in terms of tariffs and manufacturing firms that have been used to sourcing subassemblies, component parts from overseas, especially Asia. They're looking down, both barrels of a 12-gauge shotgun right now, and that the prediction is they're going to be scrambling and looking for potentially domestic sources to keep costs under control, and that's a huge opportunity for small and medium-sized manufacturing enterprises all over America. Is that going to be a sweet spot now? Are those the firms that say, look, we could be swamped with orders. We're going to have to scale up. Is that a point at which they should look at this right now?
Yeah, I think so. This is my opinion on this is that with the sort of disruption that we've seen over the last number of months, but really years, but the uncertainty that changes day to day, having AI to help you maybe see which of your 800 parts are subject to tariffs and which are not. What's that tariff amount going to be? Can you eat that cost? Is there a way to mitigate that cost, or do you have to pass it on? Uh, AI can help you, I think, decide on that much faster. I mean, if you're stuck scrolling through spreadsheets looking for which of these parts are subject to tariffs, good luck, right? I'd have fun with that because you're going to be at that for a month. And by the time you're done, everything will have changed, right? So I think that now is a time where you could very quickly find a use case for that, for a smaller, medium-sized business that makes sense and doesn't require a whole bunch of um, technological investment further down the line and onto the shop floor.
Yeah, yeah. So much to talk about, so little time to do it in. If I were to sort of tie a bow on this conversation, the obvious concluding question would be: we've just made a case now why SMEs, manufacturers of all sizes, need to take this seriously and should look at it. But if a firm wants to investigate this, where do they start? How do you begin?
Right. Well, what I would say on that is, technology is only disruptive if you're on the defense. It's transformative if you're on the offense. And so you need to start small, much like any continuous improvement program would have been 10 years ago. You do a value stream map or your Gemba walk, you find the little pockets of inefficiency that you can deal with. This is the same. You take small bites and then use the value that you've gained from that small bite to fund the next bite, you know. And by doing that, you can sort of develop this long procedural implementation of AI without taking on too much risk as a small company, you know. And I think that's probably the best way to go. You're going to need to have the digitalization journey sort of started already. If you're still working off of paper, you're not going to be able to work with AI. But if you're collecting the data through your edge devices, through your PLCs, through your PLM or ERP systems, then you've got it there, and it's there to be used, right? And data is not gold unless you use it.
Wise words. Mike Ouellette, Senior Editor, Engineering.com. Thanks for joining me on the podcast.
Thanks for having me, Jim.
That's it for today's Industry Insights and Trends podcast, brought to you by Engineering.com. If you like this program and want to keep pace with the latest innovations in engineering, subscribe to our newsletters such as Design Weekly, 3D Printing, Aerospace and Defense, Digital Transformation, Simulation, or a weekly roundup at Engineering.com/subscribe. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Designing the Future, Manufacturing the Future, and the Engineering Roundtable, found exclusively on Engineering.com TV. Thanks for tuning in.